Good afternoon, ladies and gentlemen. My name is Arnold Ochoa Jr., and I am so happy and so honored to be here today and present in this symposium. I want to thank Dr. Liu for inviting me and Dr. Han for having me. To begin with, the title of my dissertation is Efficacy of an Intervention Program for the Star Biology Exam. This was a dissertation that I concluded this semester. And so this is just a table of contents. The chapter 1 is the introduction. We'll go over chapter 3, the method, go over chapter 4, the results. Then chapter 5 with the discussion, conclusions, and recommendations. So to begin with, I'd like to introduce the background of the study. And so public schools in the state of Texas are required by the TEA to administer 5 state exams to high school students consisting of English 1, English 2, Algebra 1, Biology, and U.S. History. These exams play a big role in school accountability and in high school graduation. For this reason, many schools develop intervention programs to increase student passing rates. Now, in an effort to increase scores and the number of students achieving master's level designation in the STAR Biology exam, an intervention program titled Master's Camps was introduced at a high school in the Rio Grande Valley. Despite the great amount of time and resources that were spent planning and implementing the Master's Camps, the program was never evaluated. This study aims to fill this void by evaluating the effectiveness of Master's Camps on student scores. So the purpose of this quantitative comparative study is to examine the differences in STAR Biology scores among students who participated in an intervention program known as Master Camps 0 times, 1 time, or 2 times. The research question that guided this study was, after controlling for prior individual differences in STAR Biology scores, to what extent was there a statistically significant difference in STAR Biology scores among students who participated in 0, 1, or 2 Master Camps as an extracurricular activity? Now, the significance of the study. So, providing statistical evidence on the efficacy of this intervention could help the school study site and schools across the state allocate resources and time more effectively. In addition, it could provide the groundwork for future interventions and help boost student performance on state science exams, on 6 weeks exams, on basically, it adds to the literature in science exams or student learning in science exams. Furthermore, it adds to the literature of underperforming socioeconomically disadvantaged high schools in South Texas. It also adds to the literature of science education, and it should help boost college readiness, and you'll see, or in my study, there was research that showed that being or doing well in the STAR Biology exam helps students be college ready, or there's like a linkage between STAR Biology scores and college readiness. Now, students in the U.S. are behind their international peers in math and science academic achievement based on comparisons of international assessments. There have been several studies that have pointed that out, and this study could help add to interventions that could help increase student motivation, student engagement in science courses, and student learning in science courses that could eventually help increase these international assessment scores. Research design and rationale. So this study used a quantitative, quasi-experimental, pre-test, post-test, non-equivalent groups designed to analyze the biology STAR data of students who participated in 2 master camps, 1 master camp, and those who did not participate in any master camps. The population consisted of 366 high school students enrolled in a biology course at a comprehensive high school in South Texas. The sampling and sampling procedures. So the scores of all students who participated in 1 and 2 master camps were analyzed. The average number of these 2 groups was calculated. And then we used that number to randomly select from the control group. So the control group was the students who did not receive the master camp intervention, so that the 3 groups were roughly equivalent in number. The intervention. So the intervention was titled Master Camps, as it was said before. And these interventions, these master camps, were scheduled from 8 a.m. to 12 p.m. on 2 different Saturdays. In an effort to differentiate and maximize learning, the framework of the master camps consisted of a combination of teaching strategies. These teaching strategies were laboratory demonstrations, guided notes, videos, STAR release questions, which are just practice questions from previous STAR exams, and then thinking maps. The master camps content was derived from the 16 Biology Readiness Standards, or TEKS, that were developed by the TEA. The content targeted TEKS that aligned with the master's level performance descriptor, and each camp covered roughly about 4 TEKS. So the data analysis plan, a one-way mixed ANCOVA statistical procedure was used to determine the effect of master camps attendance, 2, 1, 0 on star scores. The SPSS version 28, I believe it was used to analyze the data. And all 10 one-way mixed ANCOVA assumptions were met. Descriptive statistics, So a total of 21 students comprised the control group, 23 students made up the the group that attended one camp, and then 18 students accounted for the 2 camps attended group. All right, so just 21 students didn't attend any camps, 23 students attended one camp, and 18 students accounted for the 2 camps, okay? So the results. So pretest scores were higher in the group of students that attended 2 master camps at 63.28 compared to the group that attended 1 camp at 60.96 points. And this is out of 100, a scale of 0 to 100. And then the control group had an average score of 55. So again, 2 master camps had a pretest score of 63.28. The group that attended 1 camp had an average score of 60.96, and the control group had an average score of 55. Now the post-test, or the STAR biology scores, were higher in the group of students that attended 2 camps, which was at 67.33 points. And the group that attended 1 camp had an average score of 67.04. This is on the STAR biology exam. And the control group had an average score of 60.76. So the students that attended 1 master's camps had the highest growth between the benchmark and the STAR biology exam, with a mean increase of 6.08 points, compared to the group that attended 2 master camps at 4.05 points, and the control group, which was 5.76 points. So after adjustment for pretest scores, the statistics, the one-way ANCOVA told us that there was no statistically significant difference in STAR scores of students attending 0, 1, or 2 master camps, with a F ratio of 258 or 0.173, significance of 0.842, and then partial eta squared of 0.006. So the small F ratio indicates there is more unexplained variance in the data that can be accounted for than by the independent variable. So out of curiosity, and given that there were indeed differences between the means of the control and intervention groups, I tripled the sample size using the same data as a quasi-bootstrapping technique. And then I ran the one-way ANCOVA analysis again. The results showed that there was a statistically significant difference at this point, right, when I tripled the data. And so we had an F ratio of 3.736, we had a significance of 0.025, and we had partial eta squared of 0.030 in STAR scores between students that attended the master camp 0, 1, or 2 times. Now, to bring this into scope or focus, a large effect size means that a research finding has practical significance, while a small effect size indicates limited practical applications. So what is this telling us? Our results indicated partial eta squared was 0.030. That's a small effect size, which means we can't, because it's a small effect size, indicates limited practical applications, but it does show promise and indicates a need for larger or a bigger sample for results to be more generalizable. So what are the recommendations? So this study supports Larrabee, Sunderland et al.'s 2019 recommendation that more research needs to be conducted about the implementation and evaluation of interventions to build a solid evidence base for effectiveness and generalizability. Now, other things that we would recommend are increased sample size, host master camps closer to the STAR exam. Maybe hosting these master camps closer to the date of the STAR exams helps with the learning retention or memory retention or content retention. So, and then to continue the use of teaching strategies used in the master camps due to the abundance of research supporting increased academic achievement by these teaching strategies. Another recommendation would be to group students by TEKS that they need improvement in. So if they're lacking skills in TEKS 6B, then group them in a master camps that just focuses on TEKS 6B. Moving on to the study implications. So the first thing is that this is a real world application. This is not a theoretical study. This intervention took place at a school in South Texas. And we get real world results. So another thing is that the study tells us that more hours of intervention does not equal higher academic achievement in STAR. And this was noticeable in the students that went to 2 master camps. Although they had higher mean scores, they had the lowest increase from the benchmark to the STAR biology or post-test. From the pre-test to the post-test, the students that attended 2 master camps had the lowest increase, average increase. And so this tells us more hours of intervention does not equal higher academic achievement in STAR. And then this is not a one-size-fits-all intervention. We could see that if the intervention had targeted students by their strengths and weaknesses, then maybe we would have different results. And then Texas House Bill 4545 called for new requirements that students who failed the STAR exam must receive 30 hours of accelerated instruction per subject failed. So in addition to providing these 30 hours of accelerated instruction, teachers also have to prepare students for the current year STAR exam. So if these 30 hours of accelerated instruction, if they could use these intervention programs that have been evaluated, that have been proven to be effective, then students could have a higher chance of passing the current year STAR exam, and it alleviates the time and effort from the teachers being spent on creating countless interventions or countless lesson plans and countless different strategies. So evaluating interventions like the master camps could help with these new 30 hours of accelerated instruction per subject failed requirement by the state of Texas. To conclude the study, or the conclusion of the study, this study highlights the importance of evaluating intervention programs and their impact on student learning and academic achievement. Additionally, the study helps by providing statistical evidence that the intervention program did not impact scores significantly with the low sample size at this particular test site. School leaders can use this information and allocate resources to discover how to improve master camps so that they are beneficial to Texas students and help them achieve the common educational goal of better STAR scores. Not only that, this adds to the literature of science. Do these teaching strategies help with student engagement, student motivation in science, student learning in science? And so by providing research-based evidence, research-based interventions and teaching strategies, the science curriculum, the science achievement of students could improve and help teachers and schools across the state of Texas improve overall in science. I want to thank you for having me here today. If you have any questions or concerns, you can email me at arnold.ochoa@students.tamu.edu. Thank you for having me today. Hope you have an amazing day. And these are just my references. Again, thank you for having me today. Look forward to hearing if you all have any questions. Thank you.